Have you ever looked at a pizza and just wondered, how would you actually measure one slice? It seems kind of complicated, right? But the math behind it is, believe it or not, surprisingly simple. So today, we're going to break down how to measure any piece of a circle, from the area of that slice to the length of its crust. Let's get right into it. So yeah, that's the big question, isn't it? How do you measure just a piece of a circle? I mean, whether it's the area of that piece or just the length of its outer edge, there's a simple, really elegant logic that covers it all. Okay, so first things first, let's get two key terms down. First up, we have the sector. The easiest way to think about a sector is that it's the whole slice of pizza. You know, the part with the cheese and toppings, the whole area. Then you've got the arc, which is just the crust of that slice. So the arc is a length, sector is the area, arc is the crust. Simple as that. All right, let's tackle the slice first. We're going to figure out exactly how to calculate the area of the sector. It makes sense, right? Before we can find the area of just a slice, we kind of need to know the area of the entire pizza. And that's a formula most of us have probably seen before. The area of a circle is just pi times the radius squared. This is our starting point, our whole. So here's the secret, and it's not really a secret at all. The area of a slice is just a fraction of the area of the whole circle. The logic is super simple. Step 1, you find that fraction. Well, a full circle is 360 degrees, so the fraction is just the angle of your slice divided by 360. Step 2, get the total area using that pi r square formula we just mentioned. And step 3, you just multiply them together. That's it. You're just finding a fraction of the total. And look at this. That logic we just walked through, well, it translates directly into the formal equation. The area of a sector is exactly what we just said. The fraction, that's x degrees over 360, multiplied by the total area, pi r squared. Okay, now let's see this thing in action. In this example, we've got a slice with a 51-degree angle and a pretty huge 16-foot radius. So we just take our fraction, that's 51 over 360, and multiply it by the total area, pi times 16 squared. And what do you get? 113.94 square feet. It really is that straightforward. Okay, we've totally mastered the slice. So now, let's focus on just the crust, the arc length. And honestly, here's the best part. We're going to use the exact same logic. So this time, our whole isn't the area. It's the total length of the crust all the way around the entire pizza. We call that the circumference, and its formula is 2 times pi times the radius. Again, we're starting with a concept that should feel pretty familiar. And just look at this. It is the exact same 3 steps. It's amazing. Step 1, find the fraction using the angle, just like before. That's your angle divided by 360. Step 2, get the total length, the circumference, which is 2 pi r. And step 3, you guessed it, multiply them. The length of your crust is just that fraction of the total circumference. And there it is, the official formula, which should look incredibly familiar by now, right? The arc length is the fraction, x over 360, multiplied by the total circumference, 2 pi r. It's the same logic. We just swapped out a different whole. Let's just apply it one more time to be sure. In this example, we have a 38-degree slice from a pizza with a 15-inch radius. So we take our fraction, 38 over 360, multiply it by the total circumference, 2 times pi times 15, and we get 9.95 inches. See? The pattern holds perfectly. So let's just zoom out for a second and really appreciate the beautiful pattern that's going on here. This isn't about memorizing 2 totally different formulas. It's about understanding one single simple idea. This slide right here, this says it all. For the sector area, you take the fraction and multiply it by the total area. For arc length, you take the very same fraction and multiply it by the total circumference. That's the key takeaway. It is always the fraction of whatever whole you're interested in. Just look at these 2 problems side by side. Totally different numbers, and they're asking for different things. One wants area, the other wants length. But the method, the core thinking behind it, is absolutely identical. You find the fraction of the circle you're dealing with, and then you just apply it to the total measurement you need. So, we've seen how to measure pieces of a circle. But to wrap this all up, let's explore a really fascinating question about what a circle even is. The source material asks this simple but kind of profound question. What if a shape had infinitely many sides? I mean, what would that shape even look like? And the answer is a circle. Think about it for a second. A hexagon has 6 sides. A shape with 100 sides is a hectagon. As you just keep adding more and more and more tiny sides, the shape gets smoother and rounder, until, at infinity, it becomes a perfect circle. And that leaves us with this final thought. A circle isn't just a simple round shape. It's this idea of infinity made visible. It's a shape that literally never, ever runs out of sides. It's kind of cool, right? Something to think about next time you see a pizza. Thanks for diving into this with me.